test tomorrow.
Yep.
And then the next test is the final.
Yeah. We'll take maybe a pop quiz over the next section if there's enough sections.
Too.
So.
5 free points.
Yeah, that's coming up here soon.
10 free
Okay.
points. Actually.
All right. Real quick. Practice guide. You need those out right now. Everyone should have received one last Thursday, somewhere in that time frame.
I might need a new
Okay.
one, honestly. I think I'll watch it.
You should look for it. Okay. All right. So practice test chapter 10. Have that out. We did vocab Friday. That was the last questions we were doing. We did this Friday. The vocab. I'm not gonna go through the words again. I just will warn you kind of what words you can expect to see here in a minute. We're gonna complete the rest of it today because it's pretty easy. We'll spend probably the most time today on 6 through 9 on the practice guide. Those take the longest because they're too open-ended. We'll talk about those probably the most today. And then the last, if you notice the last four in your semester test, which are, or not semester, but practice guide here, 10 through 13, those are the ones we did Thursday and Friday in the notes. That was the PowerPoints we were doing. So you need to know how to do those formulas. Because I warned you, they're on the test. Okay, all right. Okay, so practice guide, we're gonna finish it today. Remember, test tomorrow, I have that on the board for chapter 10. It's tomorrow. Maps testing this week. We're gonna do that Thursday, Friday. Chromebooks, you need them in class, fully charged, ready to go.
Dude, why are we doing maps tests?
So we do it twice a year to see where you're.
Do we get
Okay.
extra credit points if we get it higher?
That's garbage. I didn't even get
Yeah.
that.
All right.
I got one.
Homework. Homework from last Friday. If you were gone, I don't think anyone was. But 7:36, that's going in tonight. I'm still waiting on a couple of people to turn that in throughout all of geometry. So that's due today. 7:36. That'll be in the grade book. Book cover check, like books and book check, is Wednesday this week, the 9th, because I need to make sure that my seniors have all their books and somebody didn't accidentally pick them up, because people are grabbing books in my closet,
Book
which
checkers
are
are
some
10
books
points, right?
that are other people's.
Is it possible to be a senior in geometry?
Yeah, I have a couple. So, because they took like pre-algebra, algebra, and then they take geometry. That's their third class technically.
So basic, pre-algebra,
and then geometry. Yeah. So.
I wish I could.
And if they took their sequence out of order, they could be taking geometry last. So.
So you could do like
Math classes with it.
algebra 2 and then
Yeah,
geometry?
I wouldn't recommend it. It's too hard to do that. So.
Can you take
Can I
algebra
just-
2 as a freshman?
Can I retake geometry?
So.
Or do I have to?
Because you wouldn't get credit if you've already passed. So it'd be a waste of time.
That is true.
So.
Or you can
Alright.
fail, then you can
Okay.
take it and get credit.
All right. Questions? What we're doing today? Okay, vocab. Let's talk about this. Okay, I'm going to go through some of the words you need to be kind of keenly aware of that I can easily put on here. Radius, diameter, circumference, area.
Perimeter.
Those are easy words for a circle that we talked about in the very first
Will you
section.
put perimeter on there?
Perimeter can easily be on there.
Yeah. put that on there.
We've already talked about centers, tangents. We have secants, points of tangency, chords. We could call it a secant segment or an external secant segment, or external tangents or internal tangents. Sphere is the same definition of a circle. Remember that? Spheres are basically all the points equidistant from a central point. The only difference between a sphere and a circle in definition is that a circle says in a plane, and this is the same things. Inscribed is where you draw something inside a picture. Circumscribed is when you draw around it.
Wait,
So,
what's the 2 inscribed?
inscribed polygons or inscribed angles. There's different things. So, let's see. Minor arc, major arc. There's semicircle, which is half of a circle. Let's see. I already talked about diameter. Central angles or inscribed angles. Those are like the two comparisons. So those are like little things you need to be kind of keenly aware of. The ones that really get people are just the common sense ones, like what is the definition of a circle or what is a diameter? Like they just don't think of the definitions.
How
Go
can
through
you
your
miss
book.
that?
I don't know. So go through your book. Look at the bold words. I'm not going to pick some weird, obscure word. I'm picking the stuff we probably talked about a lot. So that's what I'm picking. You should expect about 7 to 8 blanks, and I will spread these out and put lines. I totally forgot to do that here, but I'll make sure of it. That way, the test will be probably like bumped down a little bit, and I'll make more use of that back page probably, because I didn't even use the whole back, I don't think, so I can scoot some problems down. So be kind of aware of that. Vocab words, about 11 or 12. somewhere
Wait,
in that
test
range.
tomorrow?
Same. Yeah, the test tomorrow. Yeah.
Sweet.
Okay, we're good? All right, let's jump right in. We already did number 1. Let's do number 2. We'll kind of go through this. Okay, number 2. Okay. We have to name 3 radii. The big thing I'm checking for here is, do you even know what these objects are? And number two, can you even write them correctly? Are you using the right notation? Are you using arrows? Are you doing any other things that are incorrect? So, can somebody name me one radii?
RO.
RO, okay? RO, you can switch around to OR, doesn't matter.
Do you have to make
ooh.
the line thingy?
You need to put the bar above it. Sorry, not arrows, bar. Bar above it, because it is a radius. Radius is start and stop, it has to be a segment. Okay, there's another one, what's another one? OT.
Oh.
OT. OT. Put a bar above it. Okay. Okay, you get the idea? You have to name three. Okay?
Can you
Alright.
put T-O?
Yeah, that's fine.
Okay.
Okay.
So that counts as two?
That's two of them. You need another one. Alright.
T-O.
Diameter. So you need to do another one of those.
I mean, does.
Diameter.
R-L.
R what? L. Okay, RL. Diameters. RL, put a bar above it. Or LR, I don't care how you say it. Secant.
Oh, I got this.
Okay.
S-R.
SR. Now, here's the big thing. If it's a secant, you have to put the arrows above it. Secants and tangents have to have arrows. So the secant goes through the circle twice, right? That's the definition of secant.
Two
Intersects the
arrows.
circle twice. So SR, draw the arrows. Boom, boom. All right. That's a secant. What about a chord?
RL.
Say again? RL is one. Is there another one?
A chord?
Chord. What? Not TK. Common
SR.
misconception. SR is the other one. Even
Wait,
though
how
SR
can
is a secant, SR, to make it a chord, you just put a bar. You don't put the arrows on. It's not TK. It's a common mistake. I had that a lot in the last class. TK, T is on the circle, but K isn't. That's why it's not a chord. Both have to touch the circle.
Wait, what would the other radii be though? Isn't L the part of the...
L still works.
Wait, what's the definition
Still
of a
works? Okay, I
secant?
didn't know if it was a...
What?
What's the definition of a secant?
Secant, it's a line that intersects a circle exactly twice.
So two.
It's almost just like a tangent.
And
Okay,
a second.
tangent of a circle.
LH.
LH. Now, on a tangent, like I said with secants, you have to have arrows. Secants and tangents have arrows.
How can you tell the difference between them, or do you don't?
About what?
When you're reading it off, or do you just have to look at the picture?
Look at the picture. Yeah.
I didn't know if like the tangent had one arrow. 'Cause it's-
No. So, I mean, technically, I think the definition of a tangent says it's a line's ray or segment, but I always consider them lines because they're just lines that intersect circles once. That's the definition, so I always consider them lines. Okay, can somebody name point L? Like, what's the specific name of that?
RLH.
No. What's the name of point L? Yeah, but what's the name of it? There's a specific name that goes on that picture. What? No, close.
Are you high?
No, something of tangent. It's in
Point
your
tangency.
It's the point of tangency. That's the name of it. It is called the point of tangency. It is the specific spot where the tangent line intersects a circle. It's in your vocab words up above. It's the location that the tangent line touches the circle. It's still a point on the circle, but it's a specific point. It's the point of tangency. Okay? Alright, questions, comments? I would expect something like that. I'll give you a picture, I'll ask you a series of items about it. Secants, tangents, diameters, whatnot. Okay? Names of circles, that's another common one. Again, how you name circles, you do it like that. You use the center letter, circle O. Okay.
Can you draw the picture too?
What?
Can you draw the picture?
The picture will be drawn for you.
No, I meant like name
Oh, yeah, you can do a double knock circle. Yeah, do that. Okay, 3. Let's go through that. Okay, this one. Now, here's what I'm gonna do for this one. This one's. What's going on here? That is not the right size picture. Just gonna make it bigger. Looks way bigger than yours, doesn't it?
Yep.
What's going on here? Just do your own thing here. Computer, what are you doing? Aww,
Maybe refresh it or something.
that's weird. Okay. Anyway. Oh, there it goes. There. Making up its own mind today. Alright, today, here's what I'd like you to do. On this number 3, I would like you to turn to the person next to you, forward, back, side to side, doesn't really matter how you do it. I want you to see if you can figure out number 3 and we'll talk about it. I'm going to see the first group that can figure it out, okay? Try it on your own. This is going to be one I want you to try and then I'm going to have your group share how you did it. Okay? So I'll give you 2 minutes. Let's see if you can figure out number 3. use the descriptions up above and use the picture.
Wait, what if it asks? No, never mind.
Okay,
I got it. Dude, that's so easy.
good.
Wait,
It's like you think it's hard, but then you look at it and it's easy.
so you just like. Oh, wait, I did it.
Okay, I'll give you one more minute here. I'm giving you a lot of time.
If you can add 10 plus 18, then you should take that one. So circle C is irrelevant, right?
So what?
C?
Yeah.
Is he gonna ask for the same ones in the class?
No. I'll give you a picture.
So tell me
We're done.
Got it? Okay. Okay, somebody walk me through. Who's got it? Travis, what do you got? How do you find FG?
You left me alone.
How do you find FG?
So,
That's the part we want to know.
probably wrong, but,
What do you get?
so, since A's, diameter
Okay, diameter of A.
is 8,
A, okay.
then that's 4,
This is 4. I agree with that.
okay? And then since circle B's diameter is 18,
This whole thing is 18.
then that one is 9,
9.
right? So then 9 minus 4 is 5,
This is 5. Yeah.
yeah, and then 5 plus 9
Is?
16.
Say it again.
14.
Oh, I'm stupid.
14. Boom. You get it all right up to that point. Boom. I like it. That's exactly how you do it. That's impressive. Okay? It is 14. And he did it absolutely correct. He used the diameters that you were provided. You cut those in half to find your radii. So you had the 18, cut that in half. And then to find F to G, you had to add these little pieces. How we found the 5 is we knew this whole stick had to be 9. And knowing that this is 4, this had to be 5. And then you add these two pieces together. Now, the only problem you could not do on this was find GC. GC is not possible.
Wait, what about?
Because you don't have, if they were to specifically tell you like this little piece here, or they tell you this little piece here, you could do it. But the problem is they just gave you this is 9. I have no idea what these are. Because it says C is like 11 in radii. I don't care that this is 5.5, 5.5. It doesn't matter. The problem is I don't know what these are. It's not the perfect halfway center. It could be 2 and 3.5.
So can you, like FC, can you not get that either?
FC you can technically, no, because we wouldn't be able to because they overlapped. Unless they give you little pieces of them. Okay, so you wouldn't be able to go FC. But what is FB? 5, it's already on the picture.
Cinco.
Okay, good.
Or did you eat some tacos yesterday?
I mean, was it Saturday?
It's Saturday.
Saturday, yes.
Saturday,
So,
yeah.
yes,
What's today?
7.
Yeah,
I
yesterday.
somehow I was
Says
able to
one.
get CG done. I took 5 point, well I didn't take 5.5, I took 5.5 away from 9.
Yeah, you can't do that because it
Why
didn't end up perfect. You can't. 9 isn't going all the way to CG, so you can't just go 5.5 and subtract 9 because this isn't 9. So you can't just subtract those parts. So it's one of those things. It's like it's super hard to like figure out unless they give you the little pieces. Then you can do it. Yeah. So it's deceptive because you think you could do something like that, like subtract and figure out the difference. You can't do it. So I don't know because it doesn't work out pretty. So because I don't know if they're perfectly like interacting at in the middle because by subtracting 9 and the 5.5 you're assuming that it's like the perfect middle of them. It doesn't have to be. So
I got 2 and 3.
yeah, because that by you subtracting it, that would put this part like here. It would move this circle up here, and then when you find the difference, you're finding actually this number, which is not possible because they're not crossing right up over each other. So yeah, it's a common mistake. And it seems like you could do it, but you can't. I think in the book, when they had problems like this one, they usually gave you those little chunks over by C. All right. Number 4. Okay, they're giving you the, now, I gotta pre-warn you. Number 4, these are 2 different problems. So when you do the top one, the bottom one is a completely new problem. So after we're done with this first one, we have to erase everything on the circle and then start over. Does that make sense? Like, don't use one to find the other. I'll kind of warn you that on test day, that this problem, these are 2 very, very different problems. They'll have different answers, and they're not using each other. Okay, DA. DA is 7.4. That's going here is 7.4. The question is, what is EF?
It's a half.
What, say again?
3.7.
It's half, yeah, it's 3.7. It's just half of it. It's the radius. E to F is the radius, so it's half of whatever the diameter is. So that's what you do, just write 3.7. I don't even know what the label is, but that's how you do it. Are we comfortable with radius versus diameter? I'm testing you on whether you know how to find one versus the
Wait,
other.
what's circumference?
Circumference is the distance around the circle. So now, if we're going on to the second question, so the second question now is that they want the circumference. You'll have the formulas on the board. Here's the circumference formula. It'll be probably on the board like over here somewhere. 2 pi r. Okay, that's your circumference formula. Now, they're telling me on this problem that this radius is 18 inches. Okay, so we can label these. The last one, by the way, was centimeters. All right, this is 18 inches for the total diameter. So to do this, we have to find radius. Now, there's another way to do this without radius, but what's the radius of that circle? 9, so you can plug that in. 2 times pi times 9 inches. You do your math. Well, if you just rearrange this, you get back to why I said there's a different way to do this. You could just take the diameter times pi. That gives you circumference, by the way. It's 2 times 9. But this is the exact answer. It's 18 pi's. But if you want to do the decimal, you actually multiply them together. Take 18 times 3.14. Go about 2 decimal places in. I think you get something like 56 or something like that.
56.52.
There you go. So that's the number I'm looking for. That's the circumference. So that's the
Wait,
distance.
don't you want 18 pi inches?
Wait, how did you get 9? I definitely missed
The
that.
Radius.
radii.
You have to use the radius. So you have to take the
Radii.
diameter that they gave you and cut it in half.
Don't you want the 18 though, because that's more accurate?
That's the exact answer, but I also want decimal, so I want both.
So you want both?
So, yeah. All right, now,
You just
if
said
they
decimal.
asked for area, I will have the area formula on the board because we did talk about it in class. It's pi r squared. So if this is the case you have to do, then you're going to take 9 inches. You're going to have to square it. You have to take the radius squared, which is 81, and you take that times pi. This is inches
Will
squared.
you have that on there?
Yeah, it'll be on the board somewhere. If I ask you for area, that's how you do it. You take the radius squared and take it times pi. And then again, you can do the decimal, 81 times 3.14, and you can get the number. Okay. And remember what area stands for? It's the little number of boxes inside the circle. Circumference is the distance around it. So that, 54 inches, or what is it, 56 inches, whatever it was, that's quite a ways around. That was a pretty big circle. Okay, that's in terms of inches anyway. Okay, questions, comments? Okay, perfect.
Next.
Now, 5. I need to pre-warn you this, and I'm going to kind of warn you on the test day, especially like with number 4, I kind of warn you that these are 2 separate problems. People always get confused by that. But on number 5, you need to put arcs on this problem. And I'll kind of warn you on test day as well, that you need to put arcs above these 2 problems. Microsoft Word doesn't do that. Sorry, it can't do arcs yet. You need to put arcs like this above these 2 problems. They want the arc measures of those. Sorry, I couldn't fill it in. Test day, when we're going through the directions on test day, I'll warn you of that, so hopefully you're paying attention. Okay, I want the angles for these. Now, if they give you 3 letters, I'm expecting this to be over 180 or more. If they give you 2 letters, I'm expecting something smaller. That's just what I expect. Okay?
Wait, why does that have to be over?
3 letters is a major arc, has to be 180 or more.
Even if it's DOB, or that would just be DB?
If it's going the short distance, they're at DB. If they went the long way, they'd go like DAB.
So, is a semicircle DA?
What?
If it's a semicircle, is it DA or?
You have to use 3 letters, a semicircle. So you have to go like DCA or DBA.
So it wouldn't be more than 180 just for 2.
All right. First one, they want you to go from here, C, all the way to A. That's why I use 3 letters. Make sense? To do that, you have to use the angles. What is this angle right here?
230.
180.
180. 180. and this number is 50, you just have to add those two pieces together. Remember, the angle in the inside, sometimes they label it on the inside like these, sometimes they label on the outside. If they label on the outside, you are always allowed to put them in here. That's the rule. I don't know why the book always says that, if they label them on the outside, you can just throw them on the inside like what these are doing. I tried to find a problem where they labeled them on the inside. Just makes this one easier to look at. You just add the two parts together. That's using angle addition, arc addition, I should say. That's our first postulate we had in this chapter. So that's the first one. You'd add those two pieces together, these two, to make the whole distance from C to D to A. Okay. Now the bottom one, AC, is going the short distance. So that's going from A towards C this way. Now how I know that, they use two letters. So you're going the short way around. Okay. All right, questions with what you have to do there? Okay,
Wait, so-
I think those are pretty straightforward.
We have to put an arc thing over our answer?
No, the answer will just be numbers. You just so many degrees. But on these, you have to put arcs so you know that I'm looking for that, I'm not looking for like distance.
So
If we
you
don't put
want us to
arcs,
put-
will we kind of know?
No. So like, I'm telling you to put the arcs in the beginning.
Okay.
Like, so you just have to give me the numbers. So, okay. All right, questions on number 5 though? Okay, let's move to number 6. Number 6. Okay, these are the ones I warned you today that I was going to spend the most time on 6 through, 6 through 9. The reason why we have to spend the most time on these is that they're the most open-ended. These problems, 6 through 9, were all based on arcs and angles, arcs and chords, and inscribed angles. They're mixing all three of these together because there's so many different types of problems I could throw at you. So what you're about to see here is I'll go through some of these and tell you how to do it, and you can solve it on your own in certain cases. But then there's certain problems that I'm going to throw like examples like, hey, this is a good problem I could put up here. Intent, that type of thing. Okay? Questions? Okay, all right, let's jump in and let's talk about number 6. Okay, you need to find the length of the stick. So if you want to put a little bar above this, not a bubble. It's looking for the length of the stick, not the angle. Okay, so just be careful of that. The bottom one, number 7, you need to put a bubble above number 7. Sorry, it wouldn't show up on when I printed it. So that's looking for the measure of the arc from C to D. Okay, it's kind of like what you did up above. All right, number 6, let's do this one. So on this problem, you need to find the length of x to y. That's what it wants, correct? It wants this distance. What you have to do first is you have to find this piece right here. To do that, you have a right triangle. You can see it. The radius here, part of the radius I should say, meets this chord at a right angle, and this the full radius. So you have to do Pythagoras Theorem. I guarantee one of the questions on your test in these 4 problems will be a Pythagoras Theorem problem. You have to be able to do it. You have to be able to show me that. Now, when we do the Pythagoras Theorem, it's a squared plus b squared equals c squared, right? Which one's a, b, and c? Which one's...
X.
Okay, x is what, a or b or c? Okay. What's b?
Wait, does A and B
And
matter?
c. No, a and b don't matter. C does. C has to be the one wall that doesn't touch 90.
Or
It doesn't touch 90. So when I do this math, I'm doing x squared plus 3 squared equals the 5 squared. Because the 5 is the hypotenuse, it was the C, right? That wall's by itself. We do the math. This is 9, this is 25. You subtract that over, you get 16.
Is 4.
And yeah, you get your 4, right? Now this part right here, this is 4. So what's the whole stick? 8. You double it. Because remember, when a radius meets the diameter, or when a radius meets a chord, it cuts the chord in half.
Wait, are these circles the same size?
Don't know, probably not.
6 and 7?
So no, they're not, they're just random. I've scaled them probably so they look the same. All right, now, is there any questions on that number 6? Now you're thinking, okay, Ward, you said you could do a different problem here. Yeah, because one of the problems in the book was something like this, that I remember doing in the homework. It was something like this, where they said this is 5, this is 5. They said this here was 12, and they want to know this piece, let's call this A to B. They wanted that piece, that dashed line. Okay, what you had to be able to do here is take the 12, these are supposed to be right angles in here. you're supposed to take the 12, split it in half, so what's half 12?
6.
6 and 6, so you put 6 here, and now you're just doing a right triangle to figure out that piece. Because remember, when these are the same distances, that means these 6 are the same length. So this is 6 and 6 is 12. It's 12 for that one. That was theorem
So it's
10.5.
9.
10.5. And then you do the math, you can figure it out. It'll be a decimal probably on that one. Okay. Questions? That problem is the same as the one you just did. You're just finding the hypotenuse instead, not one of the legs. So the x will be in a different spot in the Pythagorean theorem than that one. Okay, questions if that was your problem?
Mr. Ward, take a whack at what you think it is.
Let's see, 36 plus 25, 36 plus 25, what is that? 51 square root of that, 7.2.
7.81.
Okay, there you go.
Still pretty close.
Come on, Warren.
All right,
It's not 51.
next one.
Word's a little rusty from you.
Yeah. All right, number 7.
How much math do you do at your house?
Math? I don't know. As much as
I'm
anyone
gonna
probably
do
would.
this in life, okay?
How
Okay.
much math do you use besides in math
Just-
class?
I use quite a bit, more than you think.
Well, he also does like.
Do you use math in your
I
driving
probably use
car?
math where it's not necessary to use math, just to.
You're probably like-
So,
All
right.
8 more miles.
Okay.
Okay.
Okay, hey, okay, on this particular problem, since these chords are equal, then that means these arcs are the same length, like the measures of them. That was a theorem we had, I think it was like theorem 10.2 or something like that. So if the arcs are the same, the chords are the same and vice versa. It was an if and only if statement, it was
There's
biconditional.
no
So-
numbers in that.
So if this is 90, then this whole angle up here is 90, and you have to split it half and half, so it's 45.
Oh, you want
That's the
angles
idea.
in that.
So yeah, I want the measure of the angles. So that's the question. Okay. What I would expect in this type of problem, something that you could definitely put here. I would definitely expect problems like this. Let's say this is 20 degrees, and this one over here is 20 degrees, and they had something like this. 4x, and this is a 2x. Fine. Or 2x plus 10. Let's say that was my problem. Fine, fine and dandy. Since the arcs are the same,
Angle.
then that means these sticks have to be the same length.
So you have to send it to
So set 4x equals the 2x plus 10. Solve it.
Oh,
Fuck.
Okay, because remember, if the chords are equal, the arcs are the same, if the arcs are the same, the chords are the same. And that was the type of math, we did a lot of these in homework. Those are probably problems I would expect. Remember, the angle on the outside is equal to the angle on the inside. So if this, they said that was 20 degrees, this angle is 20 on the inside. That's the central angle. Be careful of that. Okay, that's what that 20 means, or that 90 over there means. Okay, we're good though?
Yep.
Okay, know your theorems on those, because that makes it a lot easier to solve. They should be easy.
Wait, is 8? Is that an isosceles term?
Which one?
8.
Definitely not. Definitely not isosceles.
Forgot what it says.
Okay, alright. Alright, so number 8. You have to find x and y, and number 9, same thing. You have to find x and y, and I'll kind of warn you of the problems I can put here. Okay, if this is x sitting here, how is it related to the arc that it looks at?
Half.
Half, so this has to be 25.
Uh-huh.
Very easy. Now, the problem is, it's not that one. It's always one of the other letters. It's the letter y. This is the one that people have problems with,
Ooh, ooh.
because you don't have an arc sitting there. Now, the thing is, you do have a diameter. You have the diameter going right through the center. They have, how they mark that is they have the O sitting there. So this whole length over here has to be 180. Well, you already know this piece is 50, so this has to be a 130, because they have to add to make 180 total. Because they add the 50 over here, and that's 30 to make a whole 180. And then you can cut that in half to find y, because y is looking at that 130. Okay, does that make sense for you to do that? Now, some people don't like that. They're like, Ward, yeah, I don't like that. I don't understand how that works. Okay,
I understand.
it's always half the arc that it looks at, because it's drawn across the picture. Now, here's the other way you can do it, if you're really not liking that. This is 25, right? We knew that one instantly. This angle is 90. How I know that? It's looking at the diameter. It has to be a right angle. It's like theorem 10 or something like that. Okay.
In like
That-
the
you have a
problem,
right
you
angle,
should write
and
this
now-
whole square in it.
Now, you have a right triangle. That's 25.
Adam.
Yeah, you have this 25 and that's a y down there in the corner. What does triangle have to add up to be?
180.
180, you can figure it out. Again, how I know this is 90? It's looking at a full diameter. The full diameter of full semicircle is 180, you can cut it in half. So that gives you the right triangle there. Question?
In the test, you should write like the little square thingy, so we don't have to assume.
Nope.
Because what if that was 89 degrees?
If they draw the circle O in there, like the center, it's telling you it's a diameter. That's the notation there. They tell you that the line's a diameter. If it wasn't a diameter, they wouldn't put the center there. They wouldn't put it as a perfect center. Like they wouldn't put O on that picture if it wasn't like a perfect diameter.
Oh.
So
Wait, so, just a second. Okay. 90 plus 25.
all right. Now,
What, 65?
now here's the type of picture I could put here. Let's say this is 40. What would the angle across from it be?
20.
20. You could put that angle anywhere you want. So I could put a problem like this. That would have to be 20 again, because it's looking at the same arc. And I could put another one.
20.
You can just keep going over and over and over and over
Well,
until
you
you
have to
figure
use
them
the
all
same
out. Okay.
points.
Yeah, you have to use, they have to land at the same spots. That was one of our theorems.
So are
we had.
those isosceles triangles?
No, they don't have to be.
Yes, they do.
So, now,
Yes, they are.
Two sides
Go
are
on.
How are they not?
go ahead. This,
Wait,
is-
Ward, what's the
does this look isosceles?
triangle?
No. Okay, the 20, see the 20?
So is that one that I have
The
drawn there?
bottom left.
This one?
No, that
That
one. That one?
Yeah.
So that angle is not equal to the angle to the right of it?
This one?
No? Yeah, that one.
This, no.
How is that not equal?
This arc doesn't have to be 40.
Aren't they base angles though?
What? Those are
I'm not, this is
I'm
not
sure.
going like perfect up and down. Are you kidding me? Are you saying that's an isosceles triangle?
I can't.
No, the other one.
This
The
one?
little baby
No.
one at the bottom.
Oh, this one?
Yes.
Yes.
No idea. Probably not. Just saying.
They look
Depends on
like
what the
this.
other arc is. Depends if this arc is 40. If that arc is 40, then yeah, it's
But they're vertical,
isosceles.
so.
Definitely not vertical. All right, moving on.
Yeah. Come on.
Other than that one of the other ones that we had in this section, if I did a box on the inside,
Ooh.
Okay. these two have to add up to be 180. That was one of our theorems. Okay, the opposite angles have to add up to be 180. So if this is 50, this is 130. If this is a 2x and this is a 70, fine, add them together, set equal to 180. Because remember, the opposite angles have to add to make 180. That was a property that we had. Questions on any of the problems I could put there?
Now let's go to 8 now.
Okay, 9, same idea. Okay, same idea here. That you can find,
That looks completely different. Looks way harder.
what's x?
60.
What?
120, it's double.
120.
Okay, 120.
Psych.
And then you can find y, because y is looking at the same arc, so it's half the arc that it looks at. Well, if that arc's 120, what's half of it? Boom, there's your y. Because remember, that's using the theorem 1013 we just used.
Why does it look like it's...
Doesn't have to be. As long as the angle that's inscribed is actually touching the circle and flicking an arc, it's always half the arc that it looks at. So they can put them anywhere they want.
My brain hurts.
Okay, last couple problems. These are based on the last few problems we did in our notes on Thursday, Friday, and these go really quick. Hopefully you're paying attention.
Was it 20?
Okay? The number 10?
Yes.
No.
I hate myself.
It's 11.
All right,
Is it 1?
here we go. Okay, what we talked about is if they cross on the inside, there's a shortcut for how you find angle number 1.
Oh, it's 40, 35.
35 is the number in the
Oh,
middle.
God.
Okay, now, if you don't like that, or you don't remember like it's half, if they cross on the inside, you could take the two arcs that it's looking at, this is where angle 1 is, you could take the two arcs it looks at, you could add them together, so this is called this A and B, this is called this C and D. Yeah, you could add A and B plus C and D together, the actual arcs, the arc measures, I should say, the angles, and then you can cut that in half.
See
But
that?
it's the same thing, it's just the number in the between them.
Well, it looks like it's like the half of it, because it's the arc and then the angle.
Yeah.
That's why I got 20, so I'm not stupid.
Now, if this was 30 and they were trying to find this one, yeah, you'd be right, that'd be 20. Because 30 is in the middle of 40 and 20. So they could do
That's
that one.
how I was going.
Alright, moving on. Let's go to 11.
Stupid blonde.
Alright, 11. They're not crossing on the inside, correct?
Correct.
You subtract these two from each other. and cut it in half. You don't add them, you subtract them and cross on the outside. 120 minus the 40, you cut it in half. That's how you find if they cross on the outside. You don't add them, you subtract them instead. There's no shortcut on this. It's not like the perfect number in between them. Okay?
So it's 40.
Sure, that's the number. I
Is
have
it?
no idea. Are we good with 11? Does everyone understand the formula there? I would, like on the first number 10, I don't expect to see work. It's the number in between. Most people can do that in their head. Number 11, I do expect to see that you're doing that formula so I can see how you come up with your answer. You would not believe how many people just try number 11. They get it wrong, they write their answer, and they missed 3-4 points that problem's worth because they don't want to show me any work.
So if you, like, say I get it right and I don't show work, I still only get 1 out of 3 points?
Yeah, technically.
Just write what you're thinking, Kevin. That's what you-
Okay, number 12. Let's go into that one.
You don't want to see what I'm.
Okay, number 12. Since these segments cross on the inside,
Sixes and.
this is the last step we did Friday. If they cross on the inside, you take one of the sticks, you multiply the 2 parts together, 3 times x, right? And then you set that equal to the other stick multiplied together, 6 times 4. And then you just solve for the 1. Now, I gotta warn you, like this is a nice pretty number, but the 1 on the test could be a decimal, because I just wanna see, are you setting it up right, are you solving it right? I don't care if it turns out to be a weird decimal.
So it's 8.
Sure. Sure. Okay, let's go to number 13. Hopefully that
Hey,
makes-
do you want us to show work on the practice guide?
Yes, always.
Kevin.
I have to redo the whole thing.
Rip.
So I give it to you so you have work to be shown. Alright, 13. This is the one I'm worried about. It's actually this problem on the back page. Because you have to use the whole stick and the piece on the outside, which they call the external secant segment. So the whole secant segment is 8. You take that times the piece on the outside of the circle, and you set that equal to the other one. The whole stick, the whole secant segment, times the external secant segment. That's how you do it. And you're probably thinking, okay, word, that's not hard. I can understand it by what they gave me. But this is the type of picture they could do to try to mess with you. They could do this. This whole thing is 8. This is x. This is 2. This is 5. And now they're going to mess with you. Because I know what people are going to do. They're going to go, okay, 8 times x, 2 times 5. They just got it wrong.
Wait, so what's this theorem and stuff?
This is the last one. This is 1017. The last theorem just did. 1060, I should say. This one said you take the whole thing, which, what's this whole piece? 7. That's why I don't need the stupid 5. I need the whole stick and the piece on the outside. The 5 was just there to help me define 7. Now you take 7 times 2, and you set that equal to the other one, x times 8.
Wait, leave that there for a second.
Okay.
So, wait, so for the
So,
one?
If they gave you the
8x
5,
and 12 times 4? Yeah.
now,
But if there's 2 different numbers,
We're doing
then.
these at tomorrow or the end of the
Tomorrow.
class day?
Tomorrow.
'Cause I need
Now.
to-
Now, for this one, the other thing that they could do to mess with you, other than doing the 5 and 2 and trying to get you to, they could do this. They could ask for this piece. Well, to do that, you have to find this x first, the piece on the outside, then you can subtract it from 8. So if you did the math here, and you did, 14 equals 8x, and you divide, you got like 1.7 something, and you put the 1.7 here, you could take 8 minus 1.7 and get your number, whatever it is.
Wait, where'd you get the 1.7?
Taking 14 divided by 8. So, if you were to do it that way.
Oh, 16.
But, because sometimes, I was thinking about the book problems they had, sometimes they wanted a piece on the inside. Well, you just take whatever you found on the outside and subtract it. So, alright, so there you go. Test is tomorrow. I think it's pretty straightforward, pretty easy. Just make sure you're taking your time on these and trying to finish them out. Try to show all the work that you can, all that good stuff. Alright, so that's it for today.